My name is Shreya Desai, and this is my Lab 1 presentation. To introduce this lab, the purpose was to use household materials to demonstrate how charges cause objects to interact, and the household materials that I used were tapes, books, phones, just to see how they would differ with the different charges. And also using these interactions to estimate electrical force. The fundamental physical principles that were used were Coulomb's law and how charges interact. And the quick summary of my results is that the U tapes are both positively charged because they repel each other. Some observations that I made were that the U tape was attracted to my hand and my phone, which would make sense because it would be attracted to neutral items. The two U tapes would repelled each other because they have the same sign charge. The U tapes attracted to the clear plastic pen, so it is positively charged, and this assumption was made from the given information that the plastic pen, when charged, was negatively charged. And assumptions were to ignore air resistance on a moving object, treat a long piece of tape as if it was a point charge, and to assume that each U tape had the same amount of charge evenly distributed along the length of the tape. Measurements that I made were the length of each tape used was zero point 0.2 meters, the mass of each tape was 0.2 grams or 0.0002 kilograms, and this was calculated through the information that was provided before. Separation distance at which tape B begins to float is 0.0304 meters, and the magnitude of the gravitational force was I calculated by doing mass times 9.1, and I got 0.001962 newtons. As I said before, gravitational force, I did m times g, and the electrical force would be the same as a gravitational force in this instance, so it would also be 0.001962 newtons. I calculated the charge on tape B by solving for Q using the electric force formula, and I got 1.419 times 10 to the negative 8 coulombs, and the corresponding number of excess electrons on tape B I got by doing the charge divided by 1.6 times 10 to the negative 19th, and I got 8.86 times 10 to the 10th. I calculated the number of atoms on the sticky surface of tape by doing the area of the tape divided by the area of the atom. So the area of the tape was 0.2 squared, divided by the area of the atom would be 4 times 10 to the 18th atoms. The ratio of the electrons to atoms, I calculated by doing the number of excess electrons calculated before by the number of atoms on the tape, and I got 2.2 times 10 to the negative 8. This is my code, and as you can see, these are my results, and the force of gravity arrow and the electric force arrow are the same size. My code, basically what I did was I stated my constants before, which include the length of the tape, the mass of the tape, the distance, which I calculated, the force of gravity, I did mass of the tape times gravity, and electric force was the absolute value of the force of gravity. And then I stated my observation location, my particle location, and I used the same Q formula that I used before to calculate the value. And below, like I said, tape 1 and tape 2, we're assuming that they're point charges, so I showed them as spheres, and then below that you can see the gravitational and the electric force arrows. So if the electrons had a positive charge and the protons had a negative charge, the tapes would still repel each other and attract neutral objects, and they would still have the same effect on each other. And it's important to handle the tapes as little as possible because it's very easy for them to transfer the charges from the tape to your hand or the tape to other objects. So in conclusion, we were able to see that like charges attract and opposite charges repel through the studies of household objects, and the piece of tape came into equilibrium when the magnitudes of the electrical force and gravitational force were equal.